Welcome back, my dear lovely students. For the next class, we have started seeing the relation for Bessel function. Already one I have done in the previous class. In today's class, we will see one more recurrence relation. Second one, second recurrence relation, that is d by dx of x to the power of minus n into j n of x, which is going to be equals to minus x to the power of minus n into j n plus 1 of x. This also by using the definition of Bessel function, first kind of order n. With the help of that only we are going to show this one, where by the definition we know that we have, by the definition, j n of x, that is equals to summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r factorial gamma of n plus r plus 1 into x by 2 to the power of 2r plus n. Now we will consider LHS and we'll show it is equals to RHS. So we will consider LHS, that is d by dx of x to the power of minus n into j n of x. Now what we will do? We will write the what is j n of x value. The definition one will frame it over here. It is equals to d by dx of x to the power of minus n into summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r factorial gamma of n plus. Sorry for the disturbance. God. Are right. N plus r plus 1 of x by 2 to the power of 2r plus n. Now the differentiating with respect to x is there. The remaining term we will write completely out of that differentiation, because the differentiation is going to be applicable to only to the x term. So that is equals to summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r factorial gamma of n plus r plus 1, then 1 divided by 2 to the power of 2r plus n, 2r plus 1 into d by dx of x to the power of minus n into x to the power of 2r plus n. If the bases are same, powers are going to be added. So which is equals to summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r factorial gamma of n plus r plus 1 into 1 divided by 2 to the power of 2r plus n into d by dx of x to the power of 2r plus n minus n. where minus n plus n will get cancelled. Summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r factorial gamma of n plus r plus 1 into 1 divided by 2 to the power of 2r plus n into d by d x of only one term it is left x to the power of 2r. Now you have to do the differentiating to only this one term. So how you are going to get that term? That is equals to summation. So how we are going to get here? That is equals to summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r factorial gamma of n plus r plus, oh what happened, plus 1 into 1 divided by 2 to the power of 2r plus n into 2r x to the power of 2r minus 1. Where this r factorial we can write, that is equals to r is equals to 0 to infinity minus 1 to the power of r into 1 divided by r of r minus 1 into 1 factorial r of r minus 1 factorial. We can write r factorial in that way. N factorial, that we can represent as an n of n minus 1 factorial gamma of n plus r plus 1 into 1 divided by 2 to the power of 2r plus n into 2r x to the power of 2r minus 1. So this r and this r will get cancelled, and this 2 you can take it to the denominator. That is equals to summation r is equals to 0 to infinity minus 1 to the power of r 1 divided by r minus 1 factorial summation of n plus r plus 1 into 1 divided by 2 to the power of 2r plus n minus 1 into x to the power of 2r minus 1. Now see the summation. Summation, it is starting from r is equals to 0 to infinity. When I am going to substitute r is equals to 0, what is going to happen here? 0 minus 1 factorial it is there. So minus 1 factorial and value is not there, so that is going to be infinity. So you are going to get, since r minus 1 factorial is equal to infinity when r is equals to 0, so the corresponding so the corresponding terms r is equals to 0 vanishes. Hence the above summation changes to r is equals to 1 to infinity. So what you're going to get here is equals to summation r is equals to 0 to infinity minus 1 to the power of r into 1 divided by, so this we are changing, no I have not changed here, it is equals to 1. Oh god. It is equals to r is equals to 1 to infinity r minus 1 factorial gamma of n plus r plus 1. 1 divided by 2 to the power of 2r plus n minus 1 x to the power of 2r minus 1, where we have to reduce this into the definition form. So in definition we are having here r factorial, but we fall down to r minus 1. So in that case what we are going to do, we will substitute this r minus 1 is equals to some variable. We will substitute r minus 1, which is equals to m, implies r is equals to m plus 1. Then r is equals to m plus 1. So what is going to happen when r is equals to 1, m is equals to 0? We are substituting here. When r is equals to infinity, m is equals to infinity. So the summation will get changed to summation m is equals to 0 to infinity minus 1 to the power of m plus 1 into 1 divided by m factorial gamma of n plus, n plus m plus 1 of plus 1 into 1 divided by 2 of 2 m plus 1 plus n minus 1. What the power is it? Then x to the power of 2 of m plus 1 minus 1. Simplify, we have to fall to the indefinition form, which is equals to summation m is equals to 0 to infinity minus 1 to the power of m into minus 1 to the power of 1. I am separating the basis, is into 1 divided by m factorial gamma of n plus 1 I will write. Then this will be plus m plus 1. 1 divided by 2 to the power of 2m plus 2 plus n minus 1 x to the power of 2m plus 2 minus 1. Summation n is equals to 0 to infinity minus 1 to the power of m into minus to the 1, 1 divided by m factorial gamma of n plus 1 plus m plus 1 into 1 divided by 2 to the power of 2m plus n plus 1 into x to the power of 2m plus 1. Now here you see the power of x, here it's missing n term. So in that case what we'll do, we will add the power n and we'll subtract the power n. It is equals to summation n is equals to 0 to infinity minus 1 to the power of n into minus 1 to the power of 1, 1 divided by m factorial gamma of n plus 1 m, oh god, plus m plus 1 into 1 divided by 2 to the power of 2m plus n plus 1 x to the power of 2m plus n plus 1, then x to the power of minus n. What I did here, I multiply, I am adding the power plus n and subtracting the power minus n. Now the remaining, this I will take out of the summation, x to the power of minus n I can write out of the summation, because summation values are for m values. Here I'm writing as an m, sorry, it's a mistake. It is m. Right. X to the power of minus n, summation m is equals to 0 to infinity minus 1 to the power of m into minus 1. This also we can write out. minus 1 divided by m factorial gamma of n plus 1 plus m plus 1 1 divided by 2 to the power of this also in the combinedly I can write x by 2 to the power of 2m plus n plus 1. Now this is in the form of the definition. In place of n we are having n plus 1. So that is equals to minus x to the power of minus n into j n plus 1. Hence proved.